All right, welcome back, everybody. This is ACT Math Crash Course Day 1. We're on Part 2, and we're going through ACT practice right now, question by question. We've got question number 13 here on the screen. Sarah's with us. Sarah, go ahead and read question number 13 loud and proud, please.
In the figure below, C is the intersection of segment AD and segment BE. If it can be determined, what is the measure of angle BAC?
Yeah, what is the measure of angle BAC? Do you see angle BAC in the question? Yeah, it's this guy right here. Okay, that guy right there. Before we think about doing any math or any operations or anything like that, let's talk about just some basic logic and basic estimation. In fact, actually, I want to go over one of the rules for mathing here. This is for geometry. Go ahead and read rule number 3 for me, please. One of my 4 main rules.
Solve geometry questions using visual estimation.
Mm-hmm. Or the bootleg ruler. That's when we're talking about lengths here. Or the bootleg protractor, which I'll show you both of those here coming up. All of the questions, all of the geometry questions on the ACT, every single one, are drawn to scale. So if you see an angle and it looks like a 90-degree angle, it's a 90-degree angle, right? Which, by the way, you can confirm with a corner of your paper, okay? Because right, they give you a piece of paper, that's a 90-degree angle right there. You need a 45-degree angle, you can fold it in half. You got a 45-degree angle, right?
Yeah.
If you see one length and it looks like, and it's marked as 10, and you see another length which is like twice that length, the unknown length is going to be 20. It's all drawn to scale. So if one length looks like it's double. If 2 lines look like they're parallel, they're parallel. Okay? For every single question on the ACT, I've never seen an exception to that. On the SAT, they'll throw some questions at you that are not drawn to scale, and they'll say not drawn to scale. But as long as it doesn't say not drawn to scale, it's drawn to scale on the SAT, and every single geometry question on the ACT is drawn to scale. Okay? So on a question like this, the math isn't too complicated if you're familiar with geometry. How familiar are you with geometry, Sarah?
I understand this question.
Yeah. Okay. Good. But especially on some of the higher level difficulty questions, it's not always obvious what the right operation is, but you can always use basic visual estimation to eliminate some obviously incorrect answer choices, and sometimes confirm the exact correct answer choice without doing a single thing. And we're going to see a number of those coming up here. If you're going to guess, take a look at angle BAC. If you're going to guess, don't even worry about the answer choice right now. If you're going to guess what, how many degrees that angle is, what would you guess?
Probably 100.
Probably 100, right? I mean, like it's bigger than 90, right?
Yeah.
Just a little bit bigger. I would guess 100 as well. Right? It's just a tad bigger than 90. Maybe 100. Could be 100. Maybe like 105 or something like that. It's possible. Could be 100. Something around there. But something between 100 and 100. Yeah, I mean, around 100 is pretty good. Okay, let's look at the answer choices real quick. I think we can eliminate a couple of answer choices right off the bat. What can we eliminate right off the bat?
It cannot be determined from given information.
Yeah, I would. I don't know if you've heard that before, but man, I've never seen that be a correct answer choice on the SAT or ACT. They're just trying to throw you off there. That's a distractor. I've never seen that be correct. They're always going to give you enough information to solve these every single time. Have you heard that before?
No, I haven't.
Okay, yeah. They give you enough. They always do. Any others we can eliminate right off the bat before we even do a calculation?
I would probably eliminate 115. That seems like a bit much, especially because you already have 35 there.
Yeah. Yeah.
That's too large.
Yeah, 115 seems like a lot. I agree with that. I think even easier, though, to eliminate is answer choice A, right?
80.
80? Yeah, I mean, it's not less than 90, right? You know what 90 degrees is, right?
It would have been.
I mean, and again, don't forget, like every SAT or every ACT, both, I suppose, give you a protractor. They give you a 90-degree angle, right? Every single piece of paper that they're going to give you, that corner is 90 degrees. So compare that to the values, right? And you can tell, okay, again, obviously this is bigger than 90 degrees, just a little bit bigger. It can't be 80, there's no way. Does that make sense? Okay. All right, so it's either B or C. Let's do the math on this. How do we find angle A? What do we do?
So every triangle adds up to 180
Yep,
degrees.
has to.
They already give you angle B is 35.
Mm-hmm.
Determine that the interior angle C is going to be the same as 45.
Yeah, that's called the vertical angles there. They have to be equal. So that's 45 degrees. And they even look equal, don't they?
Yeah.
Right? I mean, and again, that's where you can use sort of your basic logic. Even if, students watching the video might be like, I don't know what vertical angles. They look equal. Those two angles. They are. Right? So that's 45 degrees. So then A is going to just be 180 minus the other two angles. Which is what?
So 35 plus 45 equals 80 degrees.
So that's 80 degrees. So
minus 80 degrees is 100.
There you go. Which was your guess right off the bat. Now, when you guessed that, and it's correct. When you guessed that, did you look at the answer choices? Did you work it out, or did you? Maybe you worked it out already. I don't know.
I looked at the answer choices.
Yeah. Yeah.
35 and 45, 5 and 5 is 0.
Yeah.
And so, I mean, we kind of just went from there. It should be 80. And then...
Yeah. Yeah. The math is real easy here, too. Yeah. But you see how, I mean, you can really find the right answer choice with just some basic logic and basic visual estimation. Does that make sense? And on an easy question like this, the math is easy. And if you're familiar with it, want to do whatever gives you the right answer. Please, 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 please. But when we start seeing the really higher level difficulty questions, start with visual estimation. Start with it. You can eliminate some incorrect answer choices, a lot of them, sometimes all of them, using basic visual estimation. Okay? All right. I always coach that on the SAT and ACT. Let's take a look at number 14. Oh. Go ahead and read number 14 for me, please.
Antoine drew the circle graph below, describing his time spent at school in one day. His teacher said that the numbers of hours listed were correct, but the central angle measures for the sectors were not correct. What should be the central angle measure for the four subject sectors?
Okay, what are we solving for here, Sarah?
For the central angle measure of the core subject sector.
Yeah, the central angle measure for the core subjects sector. Okay. Let's make this concrete. I want to make this as concrete as possible. Okay. First, the question says the teacher said the number of hours listed are correct. Okay. So how many hours total does this chart have?
9 hours.
It's got 9 hours total. All right. So here's what I'm going to do. I'm going to draw a circle. Similar to this one. Okay. There's a nice circle tool on the whiteboard I like to use. Okay. And we need to redraw this. Let's just draw out a chart with 9 hours. You know what I'm saying? Okay. Now, how do we do that? Well, I know how to draw thirds, right? Ninths is tricky, but I know how to draw a third. That's pretty easy, right? How to draw a third of a circle? How to mark that off? So we'll separate into thirds and then separate the thirds into 3 parts. Then we'll have 9 equal parts. Does that make sense?
Yeah.
Okay, great. Let's do it. So there's something like a center point. Oh, I'm still on the circle tool. All right. There's the first part. And something like a little peace sign thing going on there. Does that make sense?
Yeah.
Okay. It's not perfect, but it's going to work. Okay. Let me make that over here a little bit more. And over here a little bit more too. Okay. There you go. That's a little bit better. All right, so let's split that guy into thirds now. And then we're going to have 9. And we're just thinking like basic logic here. We're not doing any fancy math or anything like that. Just splitting this into thirds. Splitting that into thirds. Splitting that into thirds as well. Okay? Roughly 9 equal parts. Not perfectly, but roughly. Okay. that make sense?
Yeah.
Okay. So, wait, do I have not? Hold on. Let me double check. 1, 2, 3, 5, 6, 7, 8, 9. Okay, good. All right. So, the question is, what is the central angle for the core subject? Well, how many hours is the core subject thing?
4 hours.
4 hours. Okay, so let's take 4. Do 1, 2, 3, 4. 4 hours here. Okay. And mark them off here. Okay. The question is, what's that angle for 4 hours? Does that make sense?
Yes.
Okay. Look at the answer choices. What's the right answer choice? Without doing a calculation, what's the right answer choice? Gotta be.
160.
Probably 160, right? Not like I drew a perfect 160 here, but it's got to be less than.
180.
It's got to be less than 180 because 180 is all the way across. Now again, here, like this was not drawn super well to scale. If I took like the top 4, I would get, like something like this, which might have been better actually. I was trying to avoid doing that. I think that might have been better, right? It's less than 180, clearly. Does that make sense?
Yes.
And 180 is not even an option, and it's less than 180. And there's only one answer choice that's less than 180 that's even like slightly reasonable, and that's answer choice H. I mean, look at G. Right, 80. You tell me that's less than 90 degrees. Either of those angles that we drew, less than 90 degrees. That's crazy. F and G are just ridiculous. And then J and K are both bigger than 180. And it's not bigger than 180. It's less than 180, very clearly. Does that make sense?
Yes.
Okay. How many like math operations did we do there?
None.
Did we do none?
Circle.
We freaking drew a circle, right? That's it. No math operations. Does that make sense?
Yes.
Okay. And the more you can limit that, and again, think of just like real basic concrete terms, the better off you're going to be. I mean, especially with your skill level, like you should not be getting anything wrong 1 through 14. Nothing. And probably not 1 through 30 with a little bit more practice. You should be getting 1 through 30 absolutely correct. They're real basic, as long as you conceptualize them the right way. And again, the more concrete you make them, the more you're going to conceptualize them the right way. Does that make sense?
Yes.
Okay. Is this different from how you've been approaching the test?
Yes, I don't normally use the visual aids. I normally use my calculator a lot more.
Yeah. Understand? I mean, that's how you're trained to think about math. Is operations.
Yeah.
But the secret to really nailing this test, with your intelligence, with your skill level right now, you should be getting 1 through 30, like everything right, 1 through 30. Everything. If you approach it this way that I'm showing you right now, making it concrete. So there's no operation to mess up. Does that make sense?
Yeah.
Okay.
Yeah.
Let's keep going. Okay. Question 15. I like question 15. This one bumped up the level of difficulty a bit here. Go ahead and read 15 for me, please.
This month, Cami sold 70 figurines in 2 sizes. The large figurines sold for $12 each, and the small figurines sold for $8 each. The amount of money he received from the sales of the large figurines was equal to the amount of money he received from the sale of the small figurines. Okay, so Cami sold this month.
Yeah. Okay, so we're solving for. Again, what we're solving for is always that last sentence of the question here. How many large figurines did Cami sell for the month? Okay. Cami's a dude. Okay, fine. All right. So, this is supposed to be a system of equations question. Is that obvious or no?
I guess not. I mean,
No?
I could see that you could do it like that.
Right, we've got like 2 like variables, right? There's an unknown number of small figurines and an unknown number of the large figurines, right? And then we can come up with 2 equations, and you got 2 equations, 2 unknown system of equations. Is that familiar or no? A little bit familiar? Yeah? Okay. So we can do that here. What I really recommend doing, though, is, again, making this thing concrete dealing with actual values, and this is rule number one. If we can do this by just testing actual numbers and not worrying about setting up an equation, we can't mess it up. We're going to get this right, okay? We know, for example, that he sold 70 figurines total. Small ones, or the large ones go for 12, the small ones go for 8, okay? And the question is, how many large figurines did he sell? Okay, when I'm testing values, I love doing T-charts. Let's do a T-chart here. Okay, we've got some unknown number of large figurines, some unknown number of small figurines. Does that make sense? Okay. We can test the answer choices with basic arithmetic. Okay? Because if Kame sold 20 large figurines, how many small figurines did he sell?
The same number.
Not the same, it doesn't say that.
Right. Equal to the amount of money. Oh, okay. So if he sold 20, you said 20 large,
Mm-hmm.
then he would have had to sell
50 of the small figurines, right? And we know that because in the question they said he sold 20 figurines total in 2 different sizes. So underline there, not cross that out. There we go. 70 figurines, right? So the number's got to add up to 70 of the total number of figurines between the, when you add up the large and the small, okay? And we know, the amount of money he received from the sale of figurines was equal to the amount of, okay, so the amount of money from the sale of figurines is the same. So, well, how much did he make from the large figurines? We can calculate that really easily, right? How much is that? The large figurines sold for 12. Yeah, it's just 20 times 12. What's that? What? I'm sorry, you cut out just a little bit. What did you say?
Oh, sorry, 240.
200 and... Are you sure about that? Yes, you are. Yes, you are. Yep, you're right. Yeah. You're right. I was thinking about the wrong way. $240, great. And then how much do you make from the small figurines?
So that'd be 50.
And what is that? 400. Are those equal?
No.
No, that's a silly question, right? So we clearly need a bigger number of the large figurines. Does that make sense? Does it make sense also? We're not setting an equation. We're not dealing with variables. We're just testing values. And you can do this for every single question on the ACT. There might be an exception or two where you actually have to carry out a specific algebraic operation. There might be a couple. But those are higher level difficulty questions I'd recommend you skip anyway. You can turn this into basic arithmetic. Let's test the next value, right? So A is gone. We know that doesn't work. Let's try 28 for the large figurines. How much is that going to bring in? How much money?
336.
336? Mm-hmm. And then how many small figurines will there be if there's 28 large ones?
42.
How much is that going to bring in?
336.
Hey, we found the answer.
Okay.
Any questions about that? We're good?
Yeah.
Yeah. No equation to set up, no operation to worry about. Just testing values and using basic logic.
It makes a lot more sense to plug in our answer choices rather than trying to solve it.
Yeah.
Towards the end.
Yeah. Yeah. That's especially when we get to some of the tougher questions. It is a question of testing answer choices. It is always your best strategy. Always. Is it A? No. Is it B? Yeah. I mean, if we wanted to and we had extra time to go back and confirm C and D and E aren't going to work. Come on. There's logically 50 is not going to work for the larger. It's got to be less than half, right? We might have been able to start there, just being like, well, if the large ones are more expensive, it's got to be less than half. Does that make sense?
Yeah.
For the large figurines, it can't be C, D, or E, just logically. Those are the terms you want to think in. These are real world questions. It has to work in the real world. So even if you weren't doing this, this thing, you should guess either A or B. C, D, and E are silly because the large figurines are more expensive. Does that make sense?
Yeah.
All right. That's how you approach the test. Think in concrete terms. Don't ask yourself, what's the operation? Just ask yourself how you can find the right answer, how you can test the answer choices. I have a feeling you're going to do very well on this test. With a little bit of practice. You got to practice thinking in these terms, though. Do you see do you see how much... Look, when we're in stressful situations, I've heard this before, and it really resonates with me a lot, that we don't rise to the level of our expectations, Sarah. We fall to the level of our training, right? And if you've trained a certain way, which you have, you've been doing math class your whole life, you're going to approach it that way. If that's what your training is, you're going to approach it like the math class way. Does that make sense?
Yes.
Yeah. But when you stop and start practicing thinking about these questions in really concrete terms, using basic logic, using a lot of common sense, and again, you've got to practice to approach it this way. But if you can do that, then you're going to, if that's your training, that's how you're going to approach the test. So you really have to practice answering the questions this way. Okay. With a little bit of practice, you can absolutely do it. Okay. Go ahead and read question number 16 for me, please.
A car accelerated from 88 feet per second and 20 feet per second in exactly 3 seconds. Assuming the acceleration is constant, what was the car's acceleration in feet per second? From 88 feet per second to 220 feet.
Ooh, a lot of numbers going on here. A lot of numbers. This does not look super easy. It's not obvious what to do. Okay? But yeah, let's think in concrete terms. Okay? We got a car. I'm going to draw a car. Car. Apparently it's a El Camino. That's right. And, hold on. I'm going to round that out here. I don't want it to look like it's going backwards here. There we go. I don't want to be too picky here, but I want to make sure it's going this direction. All right, is that clear? It's going in that direction?
Yeah.
Okay. All right. And that car is going, it's already going 88 feet per second to start, right? 88 feet, FPS feet per second, okay? And then it's traveling for 3 seconds. There's 1 second, 2 seconds, 3 seconds, okay? Does that make sense?
Yeah.
And it goes from 88 feet per second to 220 feet per second. Does that make sense?
Yeah.
Let me tell you, drawing this out is going to make it's going to force you to conceptualize this question the right way. If you could draw a picture, draw a picture. It seems so simple. And it is. But it's so useful. Okay, so do it. Question tells the acceleration is constant. Right? So it means it's got to go up by the same amount every second that passes. Here's 0 seconds, that's 1 second, 2 seconds, 3 seconds. Does that make sense?
Yes.
Okay. I'll bet we can look at the answer choices and eliminate some obviously incorrect answer choices that just are no way going to take us from 88 feet per second to 220 feet per second after 3 seconds. There's no way. What can we eliminate?
102.
That's too much, right? That's going to be that's 3 seconds. That's going to be like 388, something like that. You know what I'm saying? Feet per second. Yeah. That's just too much. It's way too big. Look at F.
1/44. Yeah.
Right? That's laughable. Can we agree that answer choice F is absolutely laughable?
Yeah.
Right? If it's accelerating 1/44 foot per second after 3 seconds, it's going to be like,
You're almost back up.
It's going to be barely over 88 feet per second. It's not going to get us to 220. Not even close. What's looking good?
That's the 44.
Let's try.
It's more in between both of those.
Yeah, how can we test 44? I can tell you right now, I know G is not going to work. I don't think so. Let's test 44. How do we test that?
So the acceleration would be would you do 44 times 3?
Well, see, you're
And
thinking
then-
you could do that. You could do that. That's fine, right? Because it's accelerating the same amount. I would just be like, okay, after 1 second, how fast is it going? If it's 44,
Oh, so you just add it to the.
it's going to amount to the same thing. I really strongly recommend avoiding operations if you can.
Okay.
Yeah, I mean, you're right. You're right. It would work that way if it makes sense to you and you feel very confident. Absolutely. But like, I know we're going to get this if. If after 1 second, if it's accelerated at 44 feet per second, the next, after a second, it's going to be 88 plus 44, which is what? It's like, use the old calculator here. What is that going to be?
132.
Okay, 132 feet per second. And then after another second, it's going to, we're adding 44 again, right?
176.
176. And then adding 44 again, right?
220.
Oh, 220. There we go. That's source H. Does that make sense?
Yeah.
And you see, you're right. Multiplying 44 times 3 would work just fine, too, because we're adding it 3 times, same as multiplying it by 3. When you add it by itself 3 times. Okay? And you see the difference in thinking there from going from like, okay, what is the operation, right? What numbers do I slap together? And what is the, like, we didn't do anything fancy. We just drew it out and thought about it in concrete terms. And that works for the vast majority of the questions. This is a question that throws students off because there's so many numbers flying around. Draw a picture and start thinking about it in concrete terms. You're going to get it. Okay? All right. You're going to hear a lot of that coaching about thinking in concrete terms. All right.
Mm-hmm.
Question 17. Go ahead and read this for me, please.
In a plane, the distinct lines AB and CD intersect at A, where A is between C and D. The measure of angle BAC is 47 degrees. What is the measure of angle BAD?
Yikes. Okay. A lot going on here. We're going to have to draw a picture. We have to. Because I don't even know, without drawing a picture, I can't even begin to understand what's going on with this question. We got to draw a picture. Can I see you draw a picture? We've got 2 lines, A, B, and C, D. They intersect at A. And A is between C and D. Can you draw that out on the whiteboard? You know how to do that? You understand the question?
Yes. So with these 2 lines.
We got 2 lines. And they're going to intersect at A.
So this is AB.
Great. Go ahead and label that too. Label that. Which one's A, which one's B? Great. And then CD. Where's CD going to be?
They intersect at A.
Yeah, so CD's got to hit A, right? Somewhere.
So like here?
Yeah, great. Right?
Or should it be on the line?
That's fine. No, that's on the line. I mean, it's on the line.
Okay.
Right?
So C and D.
Great. And look, if you've done this, you've conceptualized it, you're so close to solving the problem. So close. If you've done this. Okay? Mm-hmm. It says BAC is 47 degrees. So let's label that 47 degrees. Okay. And that doesn't really look like 47 degrees, does it? Now, and that's fine. It's not a big deal here. I might, if I were taking this test, just to help me conceptualize it, I might fix that.
Mm-hmm.
You know what I'm saying? Could we make BA a little bit more like 47 degrees, or BAC, could we make that a little bit more like 47 degrees? It looks something like this, right? It would look like, I don't know, I'll leave CD and I'll make it like something like that. Does that make sense?
Yeah.
Right there?
Yes.
So, in fact, let's do that. I'm gonna just to help us conceptualize it. Again, the more concrete you can make this, the better.
Okay.
So that's our new AB right here. There's our new BAC. That's 47 degrees, and we are trying to solve for what?
What is the measure of BAD?
BAD. Right, we're trying to solve this guy. That angle, right there. BAD. Does that make sense?
Yes.
Easy. We got this now. What's the right answer?
133.
Yeah. Right. It's got to be great because, and you know, of course, this line here has to add up to that's got to be 180 degrees total.
Yes.
So what angle for BAD is going to give us 180 degrees for that straight line? It's got to be 133. Right? It even looks like something like 133. Right?
Yeah.
I mean, A and B are silly. C is pretty silly when you draw something like to scale. It's either D or E, and then just find out which one adds up to 180. And that's D. Any questions about that?
No.
But do you see again, like how most of the work was really in just conceptualizing the question?
Yes.
Does that make sense? And that's always the hardest work on this test. Is thinking about it in the right terms. It's not about operations. It's about understanding the question. So focus on that. Focus on conceptualizing it. And then most of the time you know exactly what to do. Okay?
Okay.
So that's all. I'd planned on basically getting through question 17 because I usually don't get through that many more questions in 2 hours with students. You're cooking. We're rock and rolling. But that's great because we're going to get to a lot of questions in these 8 hours of this course. So I've got some others I haven't looked at yet. Haven't looked at recently. I've gone over all these, but and there may not be a specific rule on the rules for math just yet that these go over, but it's still the same strategies that still apply. Again, making things concrete and conceptualizing things the right way. Go ahead and read question number 18 for me. Oh, this one's great.
And which of the following are 1/2, 5/6, and 5/8 arranged in ascending order?
In ascending order. Okay, what does that mean, ascending order?
They're getting larger.
You're getting larger, right? We're going from smallest to greatest. Okay. Oh, boy, I've got such great news for you. You don't have to deal with fractions on the ACT. Ever. Because you got a calculator. You got a calculator. You know exactly how to do this question. You can turn those into decimals. You don't have to ever deal with fractions on the ACT. Turn those into decimals. What are they?
1/2 is 0.5. 5/6 is 0.83.
0.83, you said?
Yes.
Okay.
And 5/8 is 0.6. 63.
0.63?
0.63.
Okay, which one's the smallest?
0.5.
0.5 or 1/2. Look at the answer choices. Look at the answer choices.
Yeah, there's only one that starts with.
Only one that starts with 1/2. Come on, man. This is a joke. If you think about this the right way. This is a joke. You wouldn't believe the number of kids that are going to get stumped on this across the country. A question like this. Because they're trying to oh no, I got to find a common denominator or something. And they don't remember how to do it all. And they're going to mess something up along the way. But even think about it in very concrete terms, like a pizza. You got half a pizza and 5/6 of a pizza and 5/8 of a pizza, right? Make it concrete. Which one's the smallest? Half, right?
Yeah.
I mean, you can draw the pizzas if you want to. Not a bad idea. Or just, you got to calculate, turn to decimals. The easiest by far. But make it concrete. Does that make sense?
Yes.
Don't do operations. Think the right way. Ooh, scientific notation. Eek. Go and read number 19 for me, please.
In scientific notation, 670 million plus 700 million equals
Okay. Yikes. Well, I tell you what, you've got your calculator, right?
Yes.
Let's add those up and find out what number we get. Okay? I'm doing the same. Oh my gosh. Did your calculator do what mine did?
What did yours do?
It went right into scientific notation.
No, I could program it in the scientific notation.
Mine went right into scientific notation. Well, my iPhone did, which is funny. I don't know if anybody else, if they had calculators, would do something similar. It went right into scientific notation. What did you get?
Sorry.
It's going to be 370 million, and then 1, 2, 3, 1, 2, 3. Was that it?
Yes.
Okay. This is not difficult. I mean, a lot of students are like, oh, what is this? How do I do scientific notation? Don't, like, you know this stuff. You may not know that you know it, but you know it. Right? Like, what would 1 point, it's obviously 1.37 times something. What's 1.37 times 10? Let's start there. Let's start with what we know.
13.
What is it? Yeah, 13.7. And then 1.37 times 100, which is the same as 10 to the power of 2, right, is going to be 137. Oops, 137. Okay. Oh, now I remember exactly how scientific notation works, right? Now I remember how it works. I can do it again. 1.37 times 10 to the power of 3. Work your way up if you need to. That's 1,370. So basically what you do is you take the number of zeros, here's 1 0, and then move the decimal place over. For the number of zeros. Does that make sense?
Yeah.
Yeah. And the same thing here. We've got 2 zeros, so this is 10 to the power of 2, or 100, 2 zeros, so move it over twice. Boop, boop. Right? 3 zeros, move it over 3 times. Boop, boop, boop. Does that make sense?
Yeah.
Okay. And so, I mean, I guess you could test the answer choices. Boy, there's some right off the bat that I'm going to eliminate. They're just not. They're crazy. What can we eliminate?
1.37 times 10 to the negative 9.
Yeah, A is silly, right? Because that's gonna be smaller, right? You're multiplying that by some 1.37 by something very, very small. That's insanely small. It's not gonna be that. There's no way. That's very small.
And then you can eliminate times 10 to the 15.
Yeah, and it's not even scientific notation, right? Because scientific notation is gonna give us. It's got to be like 1 digit in front of the decimal point for scientific notation. Otherwise, it's not scientific notation. Let's go on. And then now I'm looking now that I know kind of how this works with the decimal. I'm just going to count the number of decimals up to the 1. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, or the number of places. Oh, there we go. So it's 1.37 times 10 to the power of 9. That's choice B. Any questions about that? But when I punched that into my iPhone, that's why I got that number right away. I wouldn't surprise me if some other people's calculator. It depends on your calculator. But when I actually added it, that's exactly what came up. Any questions?
No.
No? Okay.
Recommend doing it like that because, I mean, I would look at this problem and say 1.67 times 10 to the 4, 5, 6, 7, 8, 9 plus. Like, I would already get to the 9th when I see the numbers up there.
Yeah.
Because both of them are scientifically times 10 to the 9th and go from there, or would you recommend just
That's
straight
fine.
up adding them?
Well, if you put those in terms, put in scientific notation first, they wouldn't be to the 9th. It would be to the 8th, right? Because you've got like 1, 2, 3, 4, 5, 6, 7, 8. That's 6.7 times 10 to the 8. Does that make sense? Yeah.
7. Okay.
Does that make sense?
Yes.
So I wouldn't do it. I wouldn't do that. I'd just do the basic. Again, you can use your calculator. Just calculate and get that. And once you got that, just put in scientific notation.
Okay.
All right. Any questions? No? Okay. All right. Easy. Is there one question we've gone over today that you wouldn't feel pretty comfortable solving?
Not really.
Not really, right?
I can use algebra for.
Okay. Yeah. But have you been getting a perfect score 1 through 30 or no?
No.
No.
Can you go back through and see which ones you got wrong?
Yeah. Well, I mean, if you're doing any prep, like on practice tests, I mean, you'll get a pretty good sense.
Practice test.
Yeah. Okay. All right. Well, we're gonna start. And I've got some resources. I can get you links to a bunch of practice tests, and I think there's like 6 free practice tests from the makers of the ACT that are available, and that's where I got these questions from as well. Yeah, you've got to use official official ACT practice tests. Don't use third-party stuff like Barron's or like, Princeton Review or McGraw-Hill, or like you've got to use the stuff from the actual makers of the test. Okay. All right. I love question number 20. This is a tough question if you're thinking in terms of operations. It's very tough, but we're going to make it very, very easy. Go to read question 20 for me, please. Loud and proud.
For trapezoid ABCD shown below, line AB is parallel to line DC. The measures of the interior angles are distinct, and the measures of angle D is.
Yeah, when they say distinct, just means they're different. Actually, I'm not quite sure. I'll be honest. I'm not quite sure what distinct means there. I don't think we need to know that. Let's keep reading.
What is the degree measure of angle A in terms of x?
Oh gosh, isn't this just like an annoyingly, confusingly worded question? It's not super clear what they're asking us here. We're trying to find the measure of angle A in terms of x degrees. Okay. Let's do this. I want to come up with a value for x degrees. Does that make sense?
Yes.
I don't want to deal with variables. This is where you mess up. This is why you're probably not getting, even though your math is really strong, you're probably not getting a perfect score 1 through 30. You should, with practice, you should. These are all really easy questions. But let's deal with real values, not variables. What does x equal? X degrees is what?
Angle D.
What'd you say?
It's angle D.
It's angle D? Well, no, I want a number. Give me, what does x degrees look like it is? If you were going to guess.
Less than 90.
Less than 90.
Maybe like 48.
That looks like 48 degrees?
No, it's more than that.
It's more than that, right? I mean, here's 45 degrees. That's half of a 90-degree angle, right?
Mm-hmm.
That's not 45 or 48 degrees. I mean, 50 degrees, right?
50? Okay.
You say 50?
I don't know. Is that what you said? I don't know.
No, I said that's not even, it's not that, is what I'm saying. It's not 45 or
it's
50.
bigger than 50.
Oh, it's got to be bigger than 50, right? It's just a little bit less than 90, right?
Okay.
Right? I mean, here's 90. Oh, wait. That's 90.
So 70 something?
Yeah, something like 70. Just 70. It's going to make life easy. Does that make sense?
Okay.
Right? If that's a 90-degree angle, then x degrees could be 70, right? Does that make sense?
Yeah.
If that's 90? Okay. So that's a good guess. I'm going to say you can do 75. Let's just make it easy and do 70. Wonderful. So much better now, by the way. So much better, this question already. So x degrees is 70. All right. Now the question is, what's the measure of angle A in terms of, 70. Don't even worry about that yet. What's angle A? Give me a guess. What's angle A look like it is? If you were gonna
Less
guess.
than 90.
A looks like less than 90?
I don't know. I can't. It's upside down.
Do you know? Use the bootleg protractor if you need to. Use that corner. Right? That's a 90-degree angle there. Right there. Use it. Then give me an estimate. You got to think in concrete terms. All right?
Mm-hmm. So it's bigger than 90.
Oh, yeah. How many degrees bigger than 90? Not a ton.
Not very much. So I don't know, like 110 maybe?
Yeah, 110. 110. It's not just a sliver bigger than 90. That'd be like 100. 110 is a good guess, right? So let's say A is something close to, we'll say, we'll do that wavy equal sign, right? Something around 110. Does that make sense?
Yeah.
Okay. So we're dealing with real values here. Take a look at this. Does that make sense? Does X look like it could be 70 and A looks like it could be 110? Does that look reasonable?
Yes.
It's totally reasonable. Totally reasonable. Great. We're dealing with real values. All right, the question is, what is the degree measure of angle A in terms of X? Okay, so the right answer is going to give us A in terms of X. All right? So the correct answer is going to give us something close to 110 when X is 70. Look at the answer choices. Does F give us something close to 110?
Yes, because it's less than 180.
Yeah, that gives us like exactly 110, in fact, doesn't it?
Yeah.
All right, well, let's keep that. What about G? Does that give us something close to 110?
It could, yeah.
Well, what is that? What's 180 minus 0.5 times 70? What's that going to be?
So 70 divided by 2 is 35. So
yeah, so it's going to be 180 minus 35.
35.
That's going to be like 145, right? Is that right?
Yeah.
Does angle A look like 145?
No, it looks...
No, right? It's smaller than 145. I don't like G. Right? F would be better. For sure. I don't like G. It's not 145. Come on. 145 would be like a 90 and then a half of a 90. Or no, that'd be bigger than that. Right? 45 degrees is 90, so it'd be like 90-degree angle and a 55-degree angle, right next to each other. It's just not that. What about H? Oh my gosh.
No, you can't have it.
Come on. Bigger than 180? That's crazy. Look at J. Come on. K?
They're not equal.
They're not equal. Any questions about that?
No.
How easy is that when you start dealing with real values?
A lot easier.
So much easier. I literally don't know how to solve this doing algebra. I don't know. I don't care. I just don't care. Because you don't need it.
Okay.
Okay? I strongly recommend dealing with real values. Again, these are all drawn to scale. So if it looks like a 70-degree angle, it's a 70-degree angle. Looks like a 110-degree angle, it's a 110-degree angle. Good. Okay. All right. Let's do at least one more. Let's see what's next. Go and read 21 for me, please.
To get a driver's license, an applicant must pass a written test and a driving test. Past records show that 80% of the applicants pass the written test, and 60% of those who have passed the written test pass the driving test. Here's how many applicants in a random group of 1,000 applicants would you expect to get a driver's license?
Easy. Easy. We got 1,000 applicants. Okay. And it says 80% of the applicants pass a written test. Right? By the way, we could calculate how many passed the written test, right? How do we find out how many people passed the written test?
Okay, so 80% of 1,000. So
Yeah. How do we find
0.8.
80% of
All right.
1,000? That's easy, right? What do we multiply 1,000 by? What do we multiply 1,000 by?
80%.
80%, which is what? What's 80%?
0.8.
0.8. Does that make sense? Right. Does that make sense?
Yes.
Okay, so 800 pass the written test, and then 60% of those guys who pass the written test, pass the driving test.
So you just multiply 800.
Yeah. By 0.6 to find 60% of those guys. And what's that? 480. I mean, come on. It's so easy. If you know percent increase and decrease. If you know what percent means. Again, 80% just means 0.8. Because 80 divided by 100 is 0.8. 60% is 0.6. 60 divided by 100 is 0.6. Does that make sense?
Yes.
Okay. All right. Let's do one more. Ooh, I like that. All right, question 22. Go and read it for me, please.
If a, b, and c are positive integers such that a to the b power equals x and c to the b power equals y, then what does x times y do?
Eek. Okay. All right. Let's do this. I don't want to deal with variables. I want to deal with real numbers here. Okay? So let's come up with some values for a, b, and c. We'll find out what y and x equal. Multiply them, x and y, and then find out what matches up with that value. Which answer choice? Does that make any sense what I just said?
We're assigning values to a, b, and c.
Yeah, that's it, right? And then we're just going to do arithmetic. No algebra, right? Everybody messes up the operations with exponents. Everybody. But when you start dealing with actual numbers again, you just plug in your calculator. It's a breeze. All right. So let's do this. Let's make a. The temptation is to make a equal 1, but then it doesn't matter what b is. You know what I'm saying?
Yes.
So let's make a equal 2. Okay. And then we'll make b equal 3. Okay. Nope, I lied. Let's do it the other way around. Well, that's fine. This will work just fine. We got a calculator, so it's no problem. All right, so a is 2, b is 3, and then let's make c. No, I did lie. Let's do it the other way. Let's do it this way. I did lie. We're going to make a equal 3, just so we're dealing with smaller values. B is going to equal 2. Okay? Does that make sense?
Yeah.
Okay. So a is 3, b is 2, and then c, let's make that 4. Okay. Does that make sense?
Yeah.
Great. All right. So what's x equal? It's going to be easy.
X equals a to the b power, so 3 to the squared is 9.
3 squared is 9. Does that make sense? And then what's y equal?
4 squared, which is 16.
Okay. And we're trying to find xy, which is just x times y. What's that?
16 times 9, which is 144.
144. Okay, good. Oh. All right. And my whiteboard is lagging. There we go. Okay, good. Any questions so far?
No.
Great. All we got to do is find the answer choice that gives us 144. When A is 3 and B is 2 and C is 4. Does that make sense?
Yes.
Okay. Let's test the answer choices. Does F give us 144?
No.
I don't think so. That's just 3 F would be 3 times C. C is 4. And B is 2 squared. No, that's not going to be 144. It's 16 times 3. It's not 144. So F is gone. What about G?
Be 3 times C raised to the 2, which would be 8.
Well, here you got to do order of operations, right? We got to multiply. You know what I'm saying? We got to multiply.
Yes.
What's 4 to the
You
power
have to do
4?
that.
What's 4 to the power 4?
4 to the power is 256.
4 to the 4th power? Oh yeah, that's too big. And then we got to multiply that by 3. That's huge. Does that make sense?
Yes.
That's too big. That's way too big. I see some other answer choices I feel pretty comfortable eliminating now that I know that G is too big. What else is probably too big? What else?
J, probably, because
yeah. If you're just if you're raising 4 to the power 4 is too big, J is going to be like 12 to the power 4. Right?
Yeah.
That's just crazy. And that's the same as K. 12 to the power 4 when B is 2. Does that make sense?
Yeah, so H.
So let's double check. What is H? Well,
A times C.
And that's 12.
And
Right?
12 squared.
Squared, which equals 144. Bingo. H. Any questions about that?
No.
Woo! Real numbers. You don't have to memorize any fancy operations. How are you feeling about the ACT right now?
A little bit better.
Good. We're just getting started. All right, we got 3 more days together, 3 more 2-hour sessions. So you're already doing great. I'm very, very, very impressed by your skill level. Very impressed. And I think you just need a little bit of practice, and I'll guide you through it. Now, again, at the end of the course, I'm going to kind of give you a step-by-step guide on how to continue to prep on your own. And we're going to talk about the timed sort of portion of the test and all that. But let's work our way through a practice test or two and sort of look at some of the higher level difficulty questions, especially at the end. But for 1 through 30, you should be, if you know these basic concepts, they're on the basic concept cheat sheet. And all of them so far, we cover 1 through 22. It's just not that much. You have to know. You're good. Okay. All right. I will be sending you an email out with the links to the videos and with a link to the homework also. Okay, all the problem sets. So I want you to practice the problems that we went over today on your own using the strategies I'm teaching you in the class, not doing the old algebra stuff. Do it the way that I'm showing you how to do it. Draw the pictures out. Think in concrete terms. Does that make sense?
Yes.
Okay. Again, we rise to the level, or fall to the level of our training, right? We don't rise to the level of our expectations. So practice doing it this way. And you're gonna do very well in this test with some prep. I'll tell you right now. Okay? You're already doing pretty good, but like you could really bump up your score a lot with a little bit of practice. All right. Any questions for me, Sarah?
I don't think so. Thank you.
Awesome. My pleasure. And I'll look forward to seeing you next week. All right?
Sounds good.
Okay. Thanks, Sarah. Take care.